Our story begins in the vast expanse of space roughly 4.6 billion years ago. Imagine a swirling cloud of gas and dust, a nebula stretching across unimaginable distances. This nebula, a cold, dark giant, held the ingredients for our solar system. A disturbance, perhaps the shockwave from a supernova, rippled through this cloud. The disturbance triggered a gravitational collapse, pulling the nebula's heart inward. This is how our sun, a radiant ball of burning hydrogen, was born. As the sun ignited, it bathed the surrounding space in light and heat. The remaining gas and dust particles, remnants of the nebula's grandeur, orbited the newborn star. Within this swirling disk, a magnificent transformation was about to unfold. Gravity, the architect of the cosmos, began to sculpt the raw materials into celestial bodies. Our solar system was coming alive. The early solar system was a chaotic and violent place. Planetesimals, driven by gravity, collided with each other. Some collisions were destructive, shattering these nascent worlds into countless fragments. But many collisions were constructive, merging planetesimals into larger and larger bodies. This process of accretion, a cosmic dance of collision and growth, shaped the destiny of our planet. In the inner region of the solar system, closer to the sun's warmth, rocky planetesimals coalesced. These planetesimals, rich in heavy elements like iron and silicon, would form the terrestrial planets: Mercury, Venus, Earth, and Mars. Further out, beyond the frost line, where temperatures were frigid, icy planetesimals dominated. These icy bodies, composed of water ice, methane, and ammonia, would become the cores of the gas giants: Jupiter, Saturn, Uranus, and Neptune. As the planets grew, their gravitational pulls sculpted the remaining debris into asteroid belts and cometary clouds. The asteroid belt, a ring of rocky remnants between Mars and Jupiter, serves as a reminder of the solar system's tumultuous past. The Kuiper belt and Oort cloud, vast reservoirs of icy bodies far beyond Neptune, hold clues to the solar system's formation and evolution. In the midst of this cosmic ballet, a young proto-Earth was taking shape. It was a hot, molten world, bombarded by a relentless barrage of asteroids and comets. This early Earth was a far cry from the life-sustaining planet we know today. But from this fiery chaos, a defining moment in Earth's history was about to unfold. A Mars-sized object, which scientists have named Theia, collided with the proto-Earth in a cataclysmic event. The impact sent shockwaves through both bodies, melting and vaporizing vast amounts of rock. Debris from the collision was ejected into space, forming a ring of molten rock and dust around the battered Earth. Over time, the debris in this ring coalesced under its own gravity. This process mirrored the formation of planets, but on a smaller scale. Within a few million years, a new celestial body, our Moon, emerged from the wreckage of the ancient collision. The early Earth was a world in constant flux. Its surface was a magma ocean, a churning sea of molten rock. Volcanoes erupted with ferocious intensity, spewing lava and gases into the primordial atmosphere. This atmosphere, a toxic mixture of carbon dioxide, nitrogen, and water vapor, was devoid of free oxygen. As millions of years passed, the Earth began to cool. The heat from its formation and the radioactive decay of elements within its core gradually radiated into space. As the Earth's surface cooled, the magma ocean began to solidify. Heavy elements like iron and nickel sank towards the center, forming the Earth's core. Lighter elements like silicon and oxygen rose to the surface, forming the Earth's crust. The cooling of the Earth and the formation of its crust marked a turning point in its evolution. The solid crust provided a stable platform upon which continents would eventually form. The oceans, formed from condensed water vapor, began to collect in the depressions of the Earth's surface. Our planet was beginning to resemble